Yeah, good morning to one and all. So today we will discuss about Fisher index number. So what is the Fisher index number? So how we can construct how we can find out, or how we can do the Fisher index number. So previous day we discussed that what is meant by index number and what are the types of index numbers. Within the types of index numbers, so there are weighted index number and unweighted index numbers. So unweighted index number, there is a simple and relative aggregate methods. So in weighted index number, we have the in our syllabus we have the three only, that is a Laspere, Patchy, and Fisher. So last day we discussed about two things, that is a Laspere index number and Patchy index number. So today we will discuss the mainly the Fisher index number, which is very important. So if you know that how we can calculate the Fisher index number, so you can get it easily, Laspere and Patchy. Okay. So Laspere index formula is a geometric mean of Laspere and Patchy. So when you take into account that formulas with regard to the Fisher index number, so Fisher index is a geometric mean of Laspere and Patchy. So this is very important, which will come for that other examination also. So Fisher index formula is a geometric mean of Laspere index, or simple they will ask that Fisher index is the geometric mean of Laspere and Patchy index number. Okay. So then next one is a very important. There is a Fisher index is the, sorry, here typical mistake, is the ideal index number. Fisher index is the ideal index number. Fisher index is the ideal index number. So what is meant by ideal index number? So generally we discussed in the last day the Laspere and Patchy. So what Laspere index number told us? So it's a upward bias and it is a upper limit, right? So when you consider that a Patchy index number, so which is a downward bias and a lower limit. But here the Fisher index will give the average value of or middle value of the Laspere index value and Patchy index value. For example, last we discussed that we got the value, that is the 177.6 and 170 point something. So when you calculate Fisher index, it may give the results below the two ranges. I think, but it cannot give the higher range, it cannot give the lower range, but it will give the range between the Laspere as well as Patchy. So that is the case. The Fisher index is the ideal index number. And there is one more point is there. So why it is an ideal index number? Because it satisfies the TRT. It is satisfy the TRT. It satisfies the TRT and FRT. What is TRT? Time reversal test. So in the Fisher index number, we have the TRT, that is the time reversal test, and FRT, factor reversal test. So after completion of the after completion of the how we can calculate the Fisher index number only, we will come to know that what is the TRT and what is FRT. Okay. So please remember that Fisher index is a geometric mean of Laspere and Patchy. Okay. The Fisher index is the ideal index number. This is a very important question which will come for that all the examinations from the index numbers. But if you take into account PG entrance or MPhil entrance or PhD entrance or other competitive exam, NET or SET or other competitive examination, they will ask which index number is an ideal index number. Fisher index is an ideal index number. The correct option. Okay. So sometimes they will ask why the Fisher index is an ideal index number, because it satisfies the TRT and FRT test. That is a factor reversal test and time reversal test. So and then comes to that Fisher index formula. See the Fisher index. That here instead of P, we need to write the typical mistake. There is a P01. See Fisher index is a under root of summation P1 Q0, P1 into Q0 divided by sum of P0 into Q0 into sum of P1 Q1 divided by sum of P0 Q1 into 100. So under root comes only up to the this one. So we can under root cannot come under the into 100. Okay. So please remember the Fisher index is a geometric. This is a under root of. So this formula, if you remember, there's a sum of P1 into Q0 by sum of P0 Q0. It is a Laspere index value in formula into so P1 sum of P1 Q1 divided by sum of P0 Q1, which is a Patchy index formula. Am I right, dear students? So after multiplying these two, after cancel the root, when you multiply the with 100, you will get the Fisher index value. Fisher index value. So this is the thing that you can simple remember. If you know that what is the Fisher index formula, you will come to know that what is the last period and what is the patching. Sometimes they will write like this also. P01 is equal under root of L into P. L into P into 100. L is nothing but last pair value or last pair index formula into patchy value, or last pair value or into patchy value into 100. So we will get a Fisher index value. Then we will come to know that how we can calculate the Fisher index number. Have you understood about the introduction part of the Fisher index number, all the students?
Yes, sir.
Yeah. So then I would like to say one thing that earlier we told that in the last previous class, the last pair index considered as a quantity as a base year. But here in the Fisher index number, the Fisher index number consider the both. Okay, what both here? Nothing but consider the base year as a quantity and current year as a quantity. Nothing but is a mixture of the two, last pair and patchy. Okay. Then, for example, in our exam, also they will ask that Fisher, find out the Fisher price index number. Same thing, I have mentioned the same data, so don't confuse that. So last day also I mentioned the same data, commodities, A, B, C, and the price, 2000 prices and 2000 quantity, and 2020 prices and 2020 quantity. So here, so we need to go the same thing. You need to write like this in our examination. Okay. Then first we need to do just a minute. Yeah. See, first we need to know that what is our formula. So, and I'm repeating again. See, under root of summation P1 into Q0 by summation P0 into Q0. Okay, into summation P1 into Q1 by summation P0 Q1 into 100. So simple. I'm going to write. See, P1 Q0. First we need to calculate the P1 into Q0. P1 into Q0. Right. So here, what is the P1 here? Can anybody can say that? It's a 7, right? So here, see here, I am writing first one. P1 is nothing but 7 into Q0 is nothing but how much? 15. Then is equal to how much? 7 into 15, 105, right? So like this, we need to enter the data. Then 4 into 100. P1 into Q0, 4 into 100. How much? 400. Okay. Then 25 into 10. How much? 250.
250.
Right? So in that case, we need to yeah. Then after calculating this one, what we need to do? What we need to do? Summation P1 Q0. Nothing but we need to add all these three values. Okay. Here we need to go with some value. Summation P1 Q0 is equals. So 105 plus 400, 505 plus 250, 755, right? So same thing we need to write, we need to calculate the P0 into Q0. Same here, P0 into Q0. Okay. So here P0 into Q0, 5 into 15, how much? Can anybody can say that? 5 into 15, P0 into Q0. I'm going to put directly.
75.
75. Then 2 into 100, 2 into 100, 200.
200.
15 into 10, 150, right? So if you same thing, if you so here if you calculate sum of P0 into Q0 is equal how much when you had all these values?
425.
425. 425. Okay. So then, so we have done this one. See, then again, what we have to do? We need to find out P1 into Q1. So P1 into Q1, right? So what is the P1 here? 7 into 20. 7 into 20, how much? 140. Then 4 into 75, 300. Then 25 into 10, 250. Then here, sum of P1, Q1 is equal how much? P1, Q1. When you had all these three values, how much you are going to get? 690, right? 690. Then after calculating that P1, Q1, what we have to know, what we have to do, the P0, Q1. P0, Q1. So what is the P0 here? 5. Q1 is nothing but here, 20. 5 into 20, 100. Okay. Then 2 into 75, how much? 150.
150.
Then 15 into 10, 150. So when you calculate all this value, when you add all these three values, you will get P0, Q1 is equal. How much you are going to get? 400, right?
400.
Okay. Okay. Then after getting these values, simple, we can substitute in the formula. So see. Is equal. So here, if the time permits, I will put under root, or else this time not, I will put it in under root. Okay. See, I am going to write here. See, what is the sum of P1 into Q0 value? 755. 755 divided by how much? Sum of P0, Q0, 425. 425. So here, see, sorry for the interrupt. See, sum of P1 into Q0 is 755 divided by 425, then into, or else you can put like this also, no problem. Into sum of P0, P1 Q1. P1 Q1 is nothing but 690 divided by sum of P0 Q1 400. Okay. Then into 100. Into 100. Then see here, I'm not going to put that under root because it is not enabled to get the time permits will get from here. Okay, doesn't matter, but see. So when you cancel 175 by 755 by 425, how much you are going to get? 1.776, I think, right? Into 690 by 400.
1.72.
1.725, right? 1.725. Okay, so see, when you multiply these two, how much you are going to get? 1.776 into 1.725. How much you are going to get? Can anybody can calculate it?
Three 3.036, sir.
Yeah, yes, 3.06, right? So into 100. So it should be under root here also. You can put in your notes. It should be under root. Okay, here under root 1.76 is 776 into 1.725. Okay, up to here under root and into 100. So then after calculating this, after multiplying these two, you will get under root 3.06 into 100. So when you cancel under root, how much you're going to get? Can anybody can say that?
1.750.
1 point, just a minute, say under root 3.06, right? 1.74, right? I'm Anirudh or Somnath. 1.74.
1.75, sir.
1.75. Oh, if you cancel the two decimals, no problem. 1.75. Okay.
Into 0.
Into 100. Okay. So then after that, you're going to get. So after cancel that root only, you will get 1.75. Then after whatever you get 1.75, you need to multiply with 100. Okay. Then is equal 175%. Am I right, dear students? Hello?
Yes,
Somnath?
sir.
So, may I know, is it understood? So, Anirudh, Supraja, Durga Prasad,
Yes, sir. Sir.
yeah, Sanjana,
Yes,
and
sir. It's
Nandini,
clear.
Nandini, Rajeshwari, and some Navya, Sri Navya, Sai Navya, sorry. Oh.
Yes, sir.
And what about others? Vamshi, Srujan. So please write in your notes. I'm again repeating. See here, you should write as a under root like this. Here under root. So same thing you need to write like this also. Here 755 divided by 425 into 690 by 400. Okay, under root up to this one only. So into 100. Then after that, see under root. So whatever we will get, so when you cancel that 755 by 425, you will get 1.776 into when you cancel 690 by 400, you will get 1.725, right? So into 100. Then after getting these two values, you can multiply. So 1.776 into 1.725. So you will get under root 3.06 into 100. So here we need to cancel the root value. So when you cancel the root value, for example, in your calculator, you can get through calculator also. So there is some under root of x value will be there in a calculator, under root of x, under root of x. So if you enter the under root, you will get a root value in your calculator. So simple, you can write enter 3.06, 3.06. So you will get 1.749. So which is approximately 1.75. So you can get 1.75 into 100. So then after getting this, after cancel the root value, whatever you get value, that should be multiplied with the 100. So when you multiply with the 1.75 into 100, so you will get how much you are going to get? 1.75. 1.7, nothing, sorry, 175%. 175%. So I understood all the students because
Yes, sir.
yeah, okay, thank you. Then see, I'm going to show again one thing. See here another formula. See, last day we discussed about these things. For example, there is a one formula. There is another one. L into under root of L into P. What is L? See, last day we discussed, we got the L value. How much we got? Last pair value. Here, last pair value. See, 177.6, or simple you can take this one 1.776. 1.776. So under root 1.776 into P value, L into P. That's a patch value. How much we got it? 1.725. Okay. So generally, whatever we have done, this thing also, you will get like this also. L under root of L into P. So last pair value is 1.776 into P value 1.725. Okay. So when you multiply these two, L value and P value, you will get 3.06. Whatever we have done. Okay. 3.06 into 100. When you cancel the under root, you will get 1.75. 1.75. When you multiply with 100, this L into P into 100, so you will get Fisher index value. There are two ways to calculate the last pair and Fisher index number. So is it clear?
Yes, sir.
So this, for example, say you need to be clear that. So this is a very important topic which will come for that long question. Okay, in your examination, which is very important. So if you learn only this Fisher index number, you will come to know that last pair and patchy. This is a last pair formula. This is patchy formula. So when you multiply with 100, you will come to know that you can express in terms of percentage. Okay. So is it right? Is it okay?
Yes, sir.
Okay. Then so here see, when you observe the results, so the base here is nothing but 100%. So this is a fish as per Fisher index number. How much we got? 175%. So when you take into consider these two values, so here last pair and patchy. So last pair shows that upward bias, nothing but which has a 177%, right? 177.6%. But whereas patchy, so the patchy value is the lower, what is it, the downward bias and lower limit. That is a 172.5%. So when you consider that the Fisher index number, as I told you, the Fisher index is nothing but it will give the value which is which value is between that low last pair and patchy. So when you take into account these two values, see, for example, I'm going to show that see, the Fisher index is equal to how much we got it? 1.175%, right? Okay. Then earlier last pair is equal to how much we got? 177.6%. Okay. Then patchy index 172.5%. So when you observe these three values, what you observe here, see the Fisher index value is an ideal index number because it satisfies the TRT and FRT. At the same time, the Fisher index value will give you the value which is between the last pair and patchy. So see, simple. Sometimes they will ask the question. See, yeah, last pair P01. That is the P01. Last pair price index value is greater than Fisher index P01, and which is greater than patchy P01. Nothing but see. Is it visible for you? I think. This one.
Yes, sir.
Yeah, note you can always see this kind of thing. They will ask question in the examination also for other exams. See here, the last pair price index value is how much? 177.6, which is higher than the Fisher index number, and the Fisher index number which will higher than the patchy. So simple here. That's why the Fisher index number is an ideal index number, because it gives that average value of the both. Not average, we can say that exact, not average. For example, we can calculate, see whether it is average or not. See, when somebody will calculate 177.6 plus 172.5 by 2, how much you are getting it? 175.05. So which is average, we can say that average also, or it should not exact average, but it is average of last pair and patchy. But exactly what we can say that the Fisher index is nothing but is a geometric mean nothing but it is a geometric average of last pair and patchy. So I may clear this about these things. Hello, dear students. Am I
Yes,
clear?
sir.
Yes, sir.
Yes, sir.
This is very important. Okay, so then as I told you that the Fisher index number is ideal index number because it satisfies the both, that's the TRT and FRT. So there is other test also there, FRT test and TRT test. So we need to know that whether it is a FRT or TRT. So because it is not in our syllabus, but if the time permits, I will tell you that how we can calculate the TRT and FRT. Okay. Tomorrow we will discuss the topics. Yeah, what is the uses of index number? Okay, what are the uses of index number? Where we can use this kind of index number in our economics. So I hope you understood all the people. Okay, so thank you very much once again. If you like this video, please
Thank
share
you,
and
sir.
subscribe.
Sure, sir. Thank you, sir.
Okay, welcome. Bye. Shall I close the session? If you have any doubt, you can ask me now.
No doubt, sir.
No doubt.
No doubt, sir.